Good morning, students. In the last class, we discussed about some practical units for measuring the large distances and also the practical units for measuring the smaller distance. So in this today class, we will discuss some practical units that are measured for mass. That is practical unit for measuring mass. So in that first one is 1 ton. So in the first one is we call ton or 1 ton or 1 metric ton. So that is equals to 1000 kg, right? So these are the practical units for measuring the mass. So for SI unit we have kg, which is measured for the mass. Then 1 ton or we call 1 metric ton, that is equals to 1000 kg, right? So second one quintal. So 1 quintal, that is equals to 100 kg, right? So these are the practical units which are used. So 1 quintal is equals to 100 kgs. So next, one Chandrasekhar limit. So Chandrasekhar is a scientist. So they given here his name, right? So one Chandrasekhar limit, that is equals to 1.4 into, that is 1.4 times the mass of sun. So that's one we call as Chandrasekhar limit. So that is one Chandrasekhar limit, that is equals to 1.4 into mass of sun. So these are the few practical units which are used for measuring the mass, right? So in that 1 ton or 1 metric ton is equals to 1000 kgs, 1 quintal is equals to 100 kgs, and one Chandrasekhar limit is equals to 1.4 into mass of the sun, that is 1.4 times the mass of sun, right? Similarly, so these are heavy masses, right? So these are not here 1 kg, 2 kg or lighter masses. So here 1 ton, 1 quintal, 1 Chandrasekhar limit. So these are all called masses, that is heavy masses. To measure the practical units for measuring the heavy masses. So that one is ton, quintal and Chandrasekhar limit, right? So next is practical unit of large time. So in the last class we discussed about the distances. So now we discuss about the masses, and here we are going to write the few practical units for the large time. So that is large time. So in that first one is solar day. So solar is the time measurement. So that one for the larger time. So when we say that solar day, that is the time taken by the earth to complete one rotation around the sun. So that time we call as solar day. That is the time taken by the earth to complete one rotation around the sun. So that time we call as solar day. So what is solar day? The time taken by the earth to complete one rotation around the sun. For the complete of one rotation, how much it will take? That is, it will take 24 hours. 24 hours. So we can convert hour into seconds. So second is the SI unit of the time. So 24 hours into 60 minutes into 60 seconds. Then we get the solar day in terms of seconds, right? So one solar day is nothing but the time taken by the earth to complete one rotation around the sun. So that one is the solar day. So and the second one is solar year. Right here to complete the one rotation, and here complete the one revolution, that is around the sun it travels, that is the distance is one revolution. That time taken to complete one revolution is called solar year. So what is solar year? Is the time taken by the earth to complete one revolution around the sun. Right? So this one we call as solar year. That is the time taken by the earth to complete one revolution year. So completed for the one revolution, how much time it will take? So that one we call as solar year. And here for the one rotation, rotation is different from revolution. So rotation is it will rotate about its own axis. So revolution means it will travel around the another object or another axis. So that one is the revolution. That is solar year is the time taken by the earth to complete one revolution around the sun. So for that, how much it means? 365.23 days. Right? So for one solar year is equals to how many days? That is 365.23 days. That one is the solar year. Right? So solar day is 24 hours, solar year is 365.23 days. So on next, lunar month. So the third one is so lunar is nothing but the moon. So what is lunar month? So time taken by the moon to complete one revolution around the earth. So here the time taken by the moon to complete one revolution around the earth. Like here also one revolution. So that is called as lunar month. So the time taken by the moon to complete one revolution around the earth we call as lunar month. So here the time taken by the moon is how much? That is 27.3 days. Right? So this is the lunar month. We can convert days into, so each day we have 24 hours. So 24 hours have 60 minutes. So 60 minutes have 60 seconds. So if we multiply all this, then we get the lunar month in terms of seconds. Right? So the lunar month is of 27.3 days. So these are the practical unit that is used for the larger time. So and also we have the shortest and the least time or shortest time. We have to note that one. that is one shake, that is smallest unit of time. So these are the largest unit of time. So 23 days, 365 days, and that is solar year, that is 365 days, 273 days, and 24 hours. These are all the largest units of time, and here one is the smallest unit of time. So that one we call as one shade. So one shade, that is equals to 10 to the power of minus 8 seconds. So this one is the smallest unit of time. So one, that is 10 to the power of minus 8 is nothing but we have 0.80, right? So this one is the smallest unit of the time. So this time we call as one shade, and these are all the largest time, that is solar month, lunar month, and also solar day, right? So these are the practical units of the larger time, and we have the smallest unit of time is one shake, that is equals to 10 to the power of minus 8 seconds, right? So next, multiples and submultiples. Multiples and submultiples of SI units. So here what are multiples and submultiples? That is, for example, here we have, for example, I am taking kg. So kg is the unit of the mass. So kg is unit for the physical quantity. Which one is mass, right? So here k is nothing but the kilo. If we write in the long form means kilogram it is, right? So if we consider gram as the unit, so gram is also the unit of the mass, then here what it is, the kilo. So kilo is nothing but the value of the kilo we are written as 1000. So 1000 can be called as kilo. Hence these are called as submultiples of the units. So here gram is there. So gram is the unit. For that gram we are multiplied by the value, that is 1000. So 1000 can be called as kilo. So kilogram. So these are the submultiples, and these are called as prefixes. So these are called as prefix. So each and every time we can't written as, if we have this much of value, that is around 1 lakh. So every time we can't write this one as 1 lakh second. So that's why we can write in our short forms, that is 10 to the power of 5 seconds. So this can be converted into 100. So I will not take this one as seconds. 1 lakh meter, right? So this can be written in terms of 10 to the power of 5. So 10 to the power of 5 can written into 10 to the power of 2 into 10 to the power of 3. So here 100 into 10 to the power of 3, we can write 100 kilometer, right? So we can write like this. Every time we can't write 1 lakh, 2 lakh, such a bigger numerical value. So we can make it in the shorter form. So here, so these we call as prefixes. Right, for meter is the SI unit of the length, and here we written the term which is kilo. That value is 1000. So here we multiplying the value, that is we are adding the prefixes. So that one we call as sub multiples. Right. Similar way, 1 kilowatt. Right. So this is the unit of energy, that is 1 kilowatt. So that can be written as 1000 watt. So instead of writing 1000 watt, we can directly written 1 kilowatt. So these are called as prefixes, right? Kilo is the prefixes. So in the similar way, we have several prefixes. We will note down those prefixes and their values and the symbols of notations, right? So here multiplication factor. So how much we are going to multiply. So that one is the multiplication factor, and here is the prefix and symbols, right? So starts with, so for first one it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So we have 1 along with 12 zeros. So this one is the larger multiplication factor. So this can be written as 10 to the power of 12, right? So we have how many zeros? 12 zeros. That can be written as 10 to the power of 12. 3, 6, 9, and here it is 12. So 1 followed by these numbers can be written as 10 to the power of 12. So for this we given the name tera. So we call tera. So in place of, if we written terabyte, then the byte is the, we call for the memory, the unit of memory, we call that one as byte, as we already know the memory, terabyte, gigabyte. So those are all. Then tera is nothing but its the value is how much? That is 10 to the power of 12. So instead of mentioning this huge multiplication factor directly, we can write it as tera, right? So the symbol of this tera is capital T. So along with this, we can write or add the SI unit. So in the before, for example, here I have written kilometer, that is km. Here kilo is the prefix and meter is the SI unit. So if we put instead of k, here we written T, that is terameter. So here tera becomes the value 1 into followed by 12 zeros into m represents the SI unit. SI unit. So here tera is the prefix, right? So in the similar way, next one, that is 1 followed by 9 zeros. 1 followed by 9 zeros, that can be written as 10 to the power of 9. So that one be written as giga. If we take similar example for the memory, unit is byte, that is gigabyte. So its capacity is 10 to the power of 9, that is 1 followed by these zeros, right? So giga is represented by symbol capital G, because these are all bigger values. So if you observe here, so these are all bigger values, hence the symbol can written in capital letters only. If we written small g, then it has no meaning, right? So if we represent only in the capital letters, then only this one has the meaning, and this value is 10 to the power of 9, right? So next one is 1 followed by 6 zeros. So for this we can written 10 to the power of 6, and this one we call as megameter, right? So mega, the value is 10 to the power of 6, that is megabyte. We can say megabyte, gigabyte, terabyte. So these are all the, we are using this prefix in regular, that is in memories, right? So here this one is the mega and its value is 10 to the power of 6. So this one is also the bigger value, hence we can represent in the symbol capital M. Right? Mega. Next, 1 followed by 3 zeros. That is 10 to the power of 3. So this one is also the bigger value. That is the value 10 to the power of 3. We can write kilo. That is 1000 can be written as kilo. This can be used in kilometer. Right? So for this we use the symbol K. Right? So all these are in capital letters. So on the fifth, that is 10. Two zeros. That is 100. That can be written as 10 square. So here this one can be written as hectare. Right? So for this we can write the symbol H. H represents what? Hectare, and its value is 10 to the power of 2. And similarly, sixth one for this, it is 10. That is 10 to the power of 1. 10 to the power of 1 is equals to 10. So for this, we call this one as deca. Right? For this, the symbol is D A. Right? So these are the multiplication factors which have larger values. That is 10 to the power of 12, 10 to the power of 9, 10 to the power of 6, 10 to the power of 3, 10 to the power of 2, 10 to the power of 1. So tera, giga, mega, kilo, hectare, deca. So the symbols are capital D, G, capital M for mega, capital K for kilo, H for hectare, and DA for deca, that is 10. 10 can be written 10 to the power of 1. Right? So these are the multiplication factors having the larger values. Now move on to the smaller values. For that, first one is starts with the 0.1. After 10, the smaller value is 1. After that, we have that smaller value is 0.1. So the prefix is 10 to the power of minus 1. That is 1 divided by 10. That is equals to 0.1. So this prefix we call as deci. So decimeter. Right? So deci is the value is 0.1. So the symbol is small d because these are smaller values. Hence this one is taken as 0.1. That is small. That is 10 to the power of minus 1 deci, and the symbol is d. And next second one is 0.01. So here for that we can write 10 to the power of minus 2. The prefix name we call this one as centimeters, right? In the scales we are using this one, centimeters. 10 to the power of minus 2, where centi is the prefix, so this value is 0.01. And the symbol is small c. So small c represents the centimeter. So similarly, third one is 0.001. That is 10 to the power of minus 3 milli. For this one, 10 to the power of minus 3, we can say milli. So the symbol is small m. Wherever it will come, that is millimeter, then its value is 10 to the power of minus 3. Right? So in the next, 0.0024 and 5 and 1. So that is we have 6 zeros, then we can write 10 to the power of minus 6. So 0.000001. So this one is 10 to the power of minus 6, and this one we call as micro. Micro means small. So for this, the symbol we taken mu. So mu is the symbol which represents the micro. Prefix micro, and its value is 10 to the power of minus 6. So next 0. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That is 10 to the power of minus 9. That one we call as nano. Nanometer. Nanoparticles. So those are the values are very smaller. That is 10 to the power of minus 9. So the symbol is small n. Right? So next 0. 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Then we can write this one as 10 to the power of minus 10. That is angstrom. So 1 angstrom is nothing but 10 to the power of minus 10 meters. Right? So here the angstrom value is 10 to the power of minus 10. So that can be written as 8 to the power of 0. Or we can remove this one. So this one is for the standard. We can directly write it only this applicable in the meters. Then if we write here 11. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 zeros. That is 10 to the power of minus 12. So for this one we call as pico, and the symbol for that is small p. Right? So this one is the 6, and the last is 0.15 zeros 1. So that can written as 10 to the power of minus 15. That is Fermi. So this one is Fm. So one Fm is the Fermi meter, and its value is 10 to the power of minus 15. Right? So these are the multiplication factors, and these are the prefixes, and these are its symbols. Right? So these will be used regularly. That is millimeter, micrometer, so micro ohm, milli ohm, microamperes, milliamperes, nanoamperes. So these are, ampere is the unit for the current. Then nanoampere means its value is 10 to the power of minus 9 amperes. Next kiloamperes and megaamperes, that is 10 to the power of 6 amperes. So those are the few examples, right? So we have to remember this one. So this one is very important. So you have to remember these values. So these are all used while solving the problem. So everywhere they won't mention that 10 to the power of minus 12 meters. Directly we 10 to the power of minus 2 meters. Directly they mention centimeter. For each and every time we need to convert the value from centi to meters. That is from centimeters to meters, because the meter is the SI unit. So if we return any values, that is after simplification, that should be in the SI units only. Right? So for that purpose, we need to know these values. Without knowing these values, then we won't simplify the problems. If we simplify the problems without substituting these values, then the problems will get wrong. Right? So for this, we need to remember. Right? So on the next, some conversions. some conversions in length, right? So in length we can convert 1 kilometer. So already we noted in the last table, that is the value of kilo is 10 to the power of 3, that is 1000. So 1 kilometer is equals to 1000 meters, right? And we have meter, centimeter, millimeter and kilometer. So these are all the units for length or distance. So we can convert from meter to centimeter, centimeter to millimeter, or from meter to kilometer, or kilometer to millimeter. So we can convert any of these, because here we have the prefixes, that is, here we have centi, here we have milli, and here we have kilometer. So right, so here we converted 1 kilometer is equals to 1000 meters. So if we want to convert this one, that is 1 kilometer into millimeters, so what we need to do is keeping this value as it is, that is 1000 as it is. So we need which one, that is centimeter. We need to convert 1 kilometer into centimeter. Then here we have the values, that is we are multiplying the value. For this term is how much, that is 10 to the power of minus 2, because we know the value of centi is 10 to the power of minus 2. So here multiplying by the value into 10 to the power of 2, right, into 10 to the power of minus 2, right. For converting kilometer into the centimeter, then we have the value, that is first here we converted 1 kilometer is equals to 1000 meter. So from this meter we need to convert meter into centimeter. The value for the centi is 10 to the power of minus 2. So in this value, if we get the value 10 to the power of minus 2, then we can directly write 10 to the power of minus 2 into C. So for that we need to multiply this value with the 10 to the power of plus 2 into 10 to the power of minus 2. So 10 to the power of plus 2 into 10 to the power of minus 2 is equals to 10 to the power of 0, that is equals to 1. So 1 into 1000 we get 1000. So if we multiply these values, will not affect the original value, hence we are multiplying this one, right? So now we can write 10 to the power of minus 2 as C, that is 1000 into 10 to the power of 2. So whole this value can be written as Cm, right? So here we have 10 to the power of 3, here we have 10 to the power of 2, so then here become 10 to the power of 5 centimeter. That is 1 kilometer is equals to 10 to the power of 5 centimeters, right? So in the similar way we can convert, right? So this is for the one example how we convert from kilometer into centimeter. So in the similar way we can convert 1 meter. So 1 meter into, in terms of centimeter or in terms of millimeter. So we need centimeter means here keeping the first value 1, here we have 1 and here we write as it is. Then if we want to convert the meter into centimeter, then we need to multiply 10 to the power of 2 into 10 to the power of minus 2, the unit meter as it is. Then 10 to the power of minus 2 can be written as 1 into 10 to the power of 2, that is 100. So this becomes 100. So this can be written as centimeter, right? So 1 meter is equals to 100 centimeter. So if we convert this 1 meter into millimeters, then we need to multiply 1 into 10 to the power of 3 into 10 to the power of minus 3 meter, right? So this one is the 1000 and here 10 to the power of minus 3 we can written as millimeter, right? So this one, that is multiplying by 10 to the power of 3 into 10 to the power of minus 3 to this numerical value, that is 1. So if we have 5 meters, then here it becomes 5. For example, I will convert 5 meter into millimeter. Then what we will do? 5 meter, we write then 5 as it is. Any numerical value can be written. If they given 10 meter, then here we need to write 10. Here they given 60, then here we need to write 60. Right? So here we need to convert 5 meter into millimeter. Then 5 meter is equals to 5 into 10 to the power of 3 into 10 to the power of minus 3. The unit we kept as is meter. Right? So here this 10 to the power of 3. Here 5 into 10 to the power of 3 is 1000. So it becomes 5000 millimeter. There will be no difference. 5 meter is equals to 5000 millimeters. Right? So these are the conversion. Meter into centimeter, meter into millimeter, and the last one is meter into kilometer. Right? So 1 meter is equals to, we need kilo, that is 10 to the power of 3. So here we need to multiply 10 to the power of 3 into 10 to the power of minus 3 meter. So we need kilo, hence we will get this value k. That is, we know from the prefix 10 to the power of 3 is kilo. Then 1 into 10 to the power of minus 3 is, that is 10 to the power of minus 3 kilometer. So 1 meter is equals to 10 to the power of minus 3 kilometer. So if we observe by taking this example, 1 meter is equals to 10 to the power of minus 3 kilometer. If we want 1 kilometer, so that is converting from kilometer to meter, then what happens? This 10 to the power of minus 3 can written as 1 divided by 10 to the power of 3 kilometer kept as is. Then if we multiply to the LHS, that is, if we shift to LHS, then it goes to the numerator. 1 into 10 to the power of 3, that is 10 to the power of 3 meter is equals to 1 kilometer. Right? Vice versa. We can convert meter into kilometer and kilometer into meter. Right? Next, area. For example, they given the area of any object, that is area of the land or area of any object. They given area is 1 kilometer square, because length into breadth. So this can be written as 1 kilometer into kilometer. Now we need to convert this area they given in the form of kilometers. Then we need to convert into meters. Then the value of kilo is, that is 1 into 10 to the power of 3 meter whole square. Right? Because area is, the unit is meter square, that is length into breadth. Right? If we taken for length, the unit is kilometer, and for breadth the unit is kilometer. So length into breadth is kilometer into kilometer, or directly we can written kilometer square. Right? So here they given 1, hence we take this one into 1 into 10 to the power of 3 kilometer square. This one will be kept outside, right? 10 to the power of 3 meter whole square, because we know the prefix value kilo, that is 10 to the power of 3. So this one becomes 1 into 10 to the power of 3 into 2, 6 meter square, that is 10 to the power of 6 meter square. Right? So this is for the area conversion from kilometers to meter square. So in the similar way, 1 meter square. So we can convert this meter into, if we convert meter into centimeters, so this can be written as 1 meter into 1 meter. Right? For how we get the values means, 1 meter square can be written as 1 into 1. Or we can write 1 into meter into meter. Now we multiply 10 to the power of 2 into 10 to the power of minus 2 meter. First we need convert this one, and for this one 10 to the power of 2 into 10 to the power of minus 2 meter, right? So here this value becomes, here it is 100 centimeter into, here how much, that is 100 centimeter. So if you multiply these two, 100 into 100, that is 10 to the power of 4 centimeter square, right? So by this way we can convert 1 meter square into 10 to the power of 4 centimeter square, right? In the similar way we can convert 1 meter square into millimeter square, right? So this is for the area, that is length. So in the similar way we can convert mass. So 1 kg is equals to how many grams? 1000 grams. Similar, for 1 gram it becomes 10 to the power of minus 3 kg. Directly we can write, if we shift 1000 here, it becomes 1 divided by 1000, so that can be written as 10 to the power of minus 3 kg. Here we kept 1 as is, that is 1 gram. So if we solve few examples for the conversions, so we understand how to convert, right? So if we take conversion for one example, that is the volume of cube of side 1 centimeter is equals to, right? So here they given 1 cube, we need to find the volume. So each side they given 1 centimeter. We know the volume is equals to length into breadth into height. So each side they given 1 centimeter, then 1 centimeter into 1 centimeter into 1 centimeter, that is equals to 1 centimeter cube. So we have 3, then centimeter cube, right? So we need to find is equals to dash meter cube. We need to convert centimeter into meter cube. So here we know the value of centi, that is 1 into 10 to the power of minus 2 meter whole cube. We know the value of centi, the prefix value centi, that is 10 to the power of minus 2. Then it becomes minus 2 into 3, 1 into 10 to the power of minus 6 meter cube. So the final answer is 10 to the power of minus 6 meter cube, right? Next, similar example, if we want to convert the speed of the vehicle, the given speed of the vehicle is 18 kilometer per hour, right? So the given speed 18 kilometer per hour, we need to convert this one in terms of meter per second, right? So now how we convert this one? Keeping LHS, that is 18 kilometer divided by hour, right? So that one is equals to 18, the numerical value we kept as is, into, in the numerator they mention kilo, so the value of kilo is 10 to the power of 3 and unit is meter, kept as is. Next, hour, we need to convert. So in the numerator we get meter, so in the denominator we need second. So now we need to convert hours into seconds, that is 1 hour is equals to 60 minutes. So 60 minutes into 60 seconds, then it converted from hours to seconds, right? So now it becomes 18 into 10 to the power of 3 divided by 6 into 6, that is 36 into 10 to the power of 2 meter per second. So now we can shift 10 to the power of 2 to the numerator, it becomes minus 2. So hence 18 divided by 36 into 10 to the power of minus 1 meter per second, right? Or we can 6 3s are 18, 6 6 are 36, so 3 1s are 3 2s are 6. That is 1 by 2, 1 by 20. It becomes 1 by 20, or we can write 0.05 meter per second. So like this we can convert, right? So in the next class we will see few more conversions and we move on to the next topic. Okay, thank you.